Another way to determine whether a function is linear is to look at its equation. A function is linear if it is described by a linear equation. All right? What that means is a function is linear, right? If it can be described as a linear equation, just means they're the same thing, right? So if we have a function, remember we're dealing with f of x equals x plus 2, right? That's a linear function. Now what it's saying is that this can be described as a linear equation, and it totally makes sense because f of x is the same thing as y, right? And when you talk about linear equations, that's when they're talking about just using y. And when they're talking about using functions, they're talking about using f of x instead of y. So basically, they're just the same thing. So what we're going to be doing is it says a linear equation is an equation that can be written in standard form shown below. Standard form. So let's talk about, well, what is standard form? Standard form is a lovely form. It's right here. ax plus by equals c. Okay, so you need to memorize that. That is standard form of a linear equation. All right, notice that x and y are on the same side of the equal sign, right? And then there's these letters in front of them. A is in front of x, B is in front of y, and C is just over here by itself on the other side of the equation. Now what it says is A, B, and C are real numbers, okay? Remember real numbers? Those are positive, negative numbers. They can be anything. They can be decimals, they can be fractions. So this could be, 2, A could be 2, so it'd be 2x plus B could be 3, equals C could be 1/4. You just put any number in front, but know that A, B, and C actually are representing numbers right now. But it does say this, that A and B are not both 0. So it doesn't work if A and B are both 0, because if they were both 0, it would be 0 times x, which is 0, and then 0 times y, which would be 0. 0 plus 0 would be just 0. And you have 0 equaling a number. So that doesn't work. So they both, the key thing is they both are not 0, but they could, one of them could be 0, right? But just not both of them. So here are some characteristics of a linear equation. Okay, so notice that when a linear equation is written in standard form right here, x and y both have exponents of 1. All right, let's talk about exponents and what exponents are. So whenever you have something like this, x squared or x cubed or this little number up there, those little numbers are called exponents, right? So what this is saying is that x and y can only have an exponent of 1. So what does this look like? It looks just like a regular x, right? Well, there's nothing there. So does that mean that there's 0? Well, let's think about what is the number in front of x here. Well, there's no number in front of x, but actually there is a number in front of x, right? Remember, there's a 1. This means 1 times x, but nobody ever writes that. They just write x. And it's understood that there's a 1 in front of x, right? Well, that's the same thing with an exponent. There's nothing there, and when there's nothing there, it's understood that there's really a 1 there, except that 1 is hidden and we just write it as x, okay? So that's what's going on here, is that with this x and there's this y, there's nothing there, but there really is this hidden 1. So right now, they both have an exponent of 1. So that is what it's saying. It says x and y both have exponents of 1. So if for some reason there was something where this was ax squared, well, it wouldn't be a linear equation. Or 2y squared, it wouldn't be a linear equation. X and y both have to have a 1 in the exponent, which just means there can't be anything in the exponents, right? When you look at it. Another characteristic is that x and y are not multiplied together. Okay, so they can't be multiplied together. What else? X and y do not appear in denominators. Okay, so they don't appear in denominators. So that would look something like this. If we had something like y equals 2 over x. Well, x is in the denominator, so that wouldn't be a linear function. Or if we had, 4x equals 2y. Okay, y is in the denominator, so that wouldn't be a linear equation. Okay, so that's one characteristic. It also says that the x cannot appear in the exponent. So that would be something like this, like y equals 2 to the x. So that variable cannot be in the exponent. If there's a variable in the exponent, it is not a linear equation. And then the last thing is it can't be in a radical sign. Now a radical sign is just the same thing as a square root symbol. Okay, so this is a radical sign. So it's just saying, you can't have anything like this, where the variable is inside a radical symbol. All right, so those are just some of the characteristics for identifying standard linear equations in standard form. Let's look at a few examples here. So first, let's look at some examples of things that are linear. Okay, this first one, well, that's written in standard form, right? ax plus by equals c. Notice that these are added together. There is no number in the exponent, which means they both have an exponent of 1 and 1, so that's good. So this is a linear. It can be written in standard form. What about this one? Y minus 2 equals 3x. Well, at this moment, it is not in standard form, but we could write it in standard form, right? If we subtracted 3x to both sides, then we ended up with negative 3x plus y minus 2 equals 0, right? That is 0. And then you just added 2 to both sides. Well, then you would end up with something that looks like this, right? 3x. Well, it wouldn't be a minus y. Oh, what did they do? Oh, they subtracted y to both sides. Well, they just did it a little different. It's the same thing as ours. Ours is negative 3x plus y and then plus 2. That's what we ended up with right here. So I'm just kind of, it doesn't have a whole lot of space. So it can be written in standard form. The x and the y both have a degree of 1. They have a 1 in their exponent, so that's good. They're added together and they're not multiplied. So that's awesome. What about this next example here? This one, negative y equals 5x. Can this be written in standard form? And yes, it can be. We just need to get that. We'll move this y over. So we add y to both sides. And we end up with 0 equals 5x plus y. And then if we just do that symmetric property of equality and flip it, then we have, it written in standard form. Perfect, okay? Let's look at some things that aren't linear. So if you look over here, 3xy plus x equals 1. We have xy. Xy are multiplied together, and you can't do that. So that's why that's not linear. What about this? X cubed plus y equals negative 1. Well, just looking at it, we see that 3 in the exponent, so we know it's not linear. What about this one? Ooh, we have x plus 6 over y equals 12. Can you see the problem? Yes, y is in the denominator, so just looking at this, it's not linear. Okay, so if you do have a linear function, you can graph it, because for any 2 points, there's exactly one line that contains them both. So let's say any 2 points. So those 2 points, I can make a line through them. Or if I have any other 2 points, like this and this, I can make a line through them. So any 2 points, random points you put anywhere, you can make a line through them. This means you need only 2 ordered pairs to graph a line. So if you have 2 ordered pairs or 2 points, you can always graph a line. All right, perfect. So let's go ahead and look at our first example here. 3a. So what we're going to do is we're going to tell whether this function is linear, and if so, we're going to graph it. So the first thing I'm going to do is see if I can put this in standard notation, right? So to do that, I need to get the x and the y on the same side. So I'm going to subtract the 2y to both sides. and I end up with x minus 2y equals 4. Notice that with standard notation, the x is always first and then the y. So this can be written in standard form. The x and the y, there's nothing in those exponents, which means there's a 1. So that's great. They both have a 1 in the exponent. So we can say, yes, this is linear. That's supposed to be is linear. And so we just need to graph it. Now to graph it, we're going to make a table of ordered pairs here. I'm going to have some x values of just like 0, 1, and 2. But in order to do that, I need to solve this equation for y. So I'm just going to take this over here and isolate y, get y by itself. So I'm going to subtract 4 to both sides. That's going to leave me with x minus 4 equals 2y, and then just divide both sides by 2. And I end up with y equals x minus 4 all over 2. Okay, so that's what I'm going to plug in here. So y equals x minus 4 all over 2. Okay, so then I'm just going to stick 0 in and figure out what those y values are so I can plot some ordered pairs. So I'm just going to go 0. Well, this is y equals 0 minus 4 all over 2. Simplify the top, we get negative 4 over 2, which equals negative 2. So that gives me the ordered pair of 0, negative 2. Okay, now I'm going to do the same thing for sticking 1 in for x. 1 minus 4 all over 2. 1 minus 4 is negative 3 over 2. I'm just going to leave it like that. So 1, negative 3 over 2. We know 3 over 2 is the same thing as 1.5. So it's negative 1.5, but I'm just going to leave it as a fraction, improper fraction. Then we're going to do the same thing for 2. So y equals 2 minus 4 all over 2. So 2 minus 4 would be negative 2 over 2, which leaves us with negative 1. So we end up with 2, negative 1. Awesome. So now I'm just going to go ahead and plot these points. 0, negative 2 would be right here. 1, negative 3.5, 3 over 2, which is negative 1.5, would be about right there. And then 2, negative 1 would be right there. So where's my little straight edge to graph this line? And there we go. You just graph it. Make sure when you graph this linear equation, you put arrows on the end. Just means that it goes on and on forever in both directions. So that's it for the first problem. Let's go ahead and look at this second problem. So we're going to tell whether the function is linear. If so, graph the function. So this one, what do you see? Is this a linear function? Well, if you said no, you would be correct because x and y are multiplied by itself. So this is not a linear function. So there we go. It's kind of a funky box I made. Well, we'll just kind of juice it up a little bit, make it a little bit more character to hide my little flaw. There we go. That looks a little bit better, right? Okay, so it's not a linear function. On to the next. And now it's your turn to check it out. So I want you to go ahead and tell whether this is a function. If it is, go ahead and graph it. So here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out this problem. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, we're back. Let's see how you did. So we're going to tell whether the function is linear, okay? So we can tell by putting it in standard form, right? So first I'm going to put this in standard form by getting the x and the y on the same side. So I'm going to subtract 5x to both. So I end up with negative 5x plus y equals negative 9. Okay, so we can write this in standard form. X and y, they're added together, so that's great. They're not multiplied. And also, there's nothing in the exponent, which means there's actually a 1 there. So that really meets all of the qualifications. So yes, this is a linear function. Now we just need to go ahead and graph it. So this is nice, it's already solved for y here. So I'm just gonna write that here. And then I'm gonna pick some values just like 0, 1, and 2. And then just go ahead and substitute those in. So y equals 5 times 0 minus 9. 5 times 0 is 0. So we have 0 minus 9, which is negative 9. So that's 0.0, negative 9. All right. Let's go ahead and do the next one. Y equals 5 times 1 minus 9. 5 times 1 is 5 minus 9. That is negative 4. So we end up with 1, negative 4. And then we have 2. So we substitute 2 in to the equation. 5 times 2 is 10. 10 minus 9 is 1. So we end up with 2, 1. All right, perfect. Now let's go ahead and just graph these points. So 0, negative 9 would be here. 1, negative 4 would be here. 2, 1 would be here. And then we just need to graph those points. Make a line, connect them. And there we have it. We have our beautiful, lovely linear function right there. So if you got that right, awesome job. Let's go ahead and look at the next example, 3b. So here's my friend the pause dragon. Go ahead and pause your device. Go ahead and work out this problem. When you get done, press play and we'll talk about it. Okay, so let's see if we can write this in standard form. Let's see how you did. So we want to have the x and the y on the same side. Now there is no x, right? So that means that there's actually a 0 in front of x. And there's no number in y, which means there's a 1, and that's okay, right? So, yeah, we can write this in standard form. 0 times x is 0, and that's why we just have y equals 12. There's an exponent of 1. And so, yeah, this is, you can write it in standard form. And so we're just going to graph it. We know if we put in the values like 0, 1, and 2, y is 12. So y is always going to be 12. So 0, 12, 1, 12, 2, 12. Y is always 12. So 0, 12, 1, 12, 2, 12. And that's really our linear equation, is just a lovely horizontal line. All right, you see that? So if you got that right, awesome job. If not, go ahead and fix your work so it looks like mine. And then let's go ahead and look at the next example. Check it out, example 3C. So here's my friend the pause dragon. Go ahead and pause, work that problem out. When you get done, press play and we'll talk about it together. All right, let's see how you did. So we're supposed to tell whether this function is linear. If so, graph the function. What do you see? Yes, there's an x in the exponent. So this is not a linear function. And that's it. All right, if you got all those correct, yoke ni gimasha, you did a wonderful job, and we'll see you in a little bit for example 4.